Hello again, and I want to talk to you guys about complex fractions. All remember, a complex fraction is just fractions inside of fractions. I think we touched on that a little bit, but we can touch on more as we go forward. And I gave you these examples of complex fractions and what they look like. So we can build off of that. Remember, it's just fractions inside of fractions. The other way you can write the reason why this is a complex fraction is because x to the negative first equals 1 over x. So that means this whole thing can be rewritten. That being 1 over x minus this being 1 over y. This in the bottom being 1 over x squared. And this right here being 1 over y squared. So you can see now it's a complex fraction. Fractions inside of fractions. Let me show you the first method of how to deal with complex fractions. First, you'll simplify the numerator and the denominator separately. In other words, take care of the top, take care of the bottom. We'll deal with the fraction I just gave you with numbers. If I'm just taking care of the top, least common denominator being 12, so I'm really multiplying this by 2. It means I got to multiply that by 2. And down here, remember, this is over 1. So that means I'm multiplying that bottom by 9 and I'm multiplying this part by 9. So if I'm taking care of each one of those, then I should end up with 7 minus 2 over 12 in the top, 18 plus 4 over 9 in the bottom. Now, separate fraction problems. And once I solve it, I should get 5 twelfths over 22 over 9. Now, here's the thing. This is a division problem, ladies and gentlemen. In other words, this is really 5 twelfths divided by 22 over 9. So you guys already know when you're dividing by a fraction, you flip and multiply by the reciprocal, right? So really, that's really 5 twelfths times 9 over 22. And you should be left with 15 over 88. So there's another method that we can use to get the same exact answer. The second method that we have is you're multiplying the entire fraction by the lowest common denominator of the whole thing. So you're taking each denominator and you're trying to find the lowest common denominator of the entire fraction. So if you're trying to do that, notice here the denominators we have. I'll write it up here. We have 12, 6, 9 as our denominators. So we have to find out how we can, what's our least common. So here, let's just find out what the lowest common multiple is of this, and we will find our least common denominator. What you'll notice is the lowest common denominator, or the lowest common multiple between all three of these, is going to be 36. So if I multiply the top by 36 and multiply the bottom by 36, let's see what happens. Distributing this 36, right? So you're multiplying 36 times 1/6 and 36 times 7/12. The 36 cancels with the 6. However, if you're doing that, you're multiplying this 1 by 6, because that's what's left over after you do 36 divided by 6. Next, that 12 cancels out, and you're multiplying that 7 by 3. Now, the reason why that works is because if I distributed that 36, then I'm really doing 36 times 7/12 minus 36 times 1/6. And I'm canceling those out. I'm left with a 3. Cancel these out, left with a 6. It works the same way. I just shorthanded it. That's all. Here, this 36 cancels with that 9. And all I'm left with is whatever I'm multiplying this numerator by. Should be left with what, 4? However, notice here, this is just 1 right here. So I'm multiplying that entire 2 by 36. So after doing all of that, I should end up with 21. What this does is that gets rid of all the denominators. So you're just left with your numerators. 21 minus 6 over 72 plus 16. Based on that, I get 15 over 88, just like I did in the last method. So that's how you actually do it with numbers. Now let's do it with actual letters. first way. If I do this with the first method, I just take care of the top, take care of the bottom. Let me take care of the top here first. The denominator, this is over 1. So this is really going to be, I'm assuming z squared over z minus 1 over z here. And that's the numerator. In the denominator, this is still over 1. So that's going to be z over z minus 1 over z. So I see my entire problem there. And let's help this out. That means that you have z squared minus 1 over z over z minus 1 over z. And really, remember, you're dividing by a fraction. So this actually turns into a multiplication problem. This multiplication problem is really z squared minus 1 over z times z over z minus 1. All I did was just take this one, flip it, multiply. So let's actually see what happens when we do this. Notice the z squared minus 1 is a difference of perfect squares. So I can actually rewrite z squared minus 1 as z plus 1, z minus 1. The z minus 1's cancel, the z's cancel. All I'm left with is z plus 1. See if it'll work with the second method. With the second method, remember the least common denominator of the entire thing. So I'm going to multiply the numerator. Since my lowest common denominator is z, multiply the numerator by z. Multiply the entire denominator by z. Remember, you're distributing that z. So if I'm distributing it, let's understand the fraction I'll be left with. This, if I distributed z times z, that's going to be z squared. And here the z's are going to cancel out, and I'll just have minus 1 over, distributing that z, that's going to be z, because that's z times 1, and then z times 1 over z, the z's cancel out, minus 1. Factored form, z plus 1, z minus 1 over z minus 1. Cancel those out. All I'm left with is z plus 1. So you can see how this works both ways. So let me actually try it with, let's see which one I'm going to do. Let's actually do, well, we did one like that. Let's do one like this. If I'm doing this problem like this, I'm going to use method 2 on this problem. Because my lowest common denominator, I have an x plus 4, I have an x. So I'm going to multiply the bottom by x times x plus 4, because that's my lowest common denominator. And I'm going to multiply the top also by x times x plus 4. Now doing that, let's see what happens. When you multiply the top, the x plus 4 is canceled. So all I should be left with is 5x. Down here, depends on where I'm distributing. If I cross out this x plus 4 with that x plus 4, I'm left with x. I'm distributing, remember. So we also got to deal with it here as well. With this one, that x cancels out, and I'm multiplying this 2 right here by x plus 4. So what I have now is x plus 2 times x plus 4. And all of that's going to equal, 5x over, x plus 2x plus 8. So 5x over 3x plus 8. Now we can't simplify any further, so we just leave it just like that. So that gives you an idea of how we actually do some of these. So since that tells you how to do some of these, you should be able to do some on your own.